pH. And then example 2 is, it says, how much gas will be produced? How much gas will be produced if 2.5 grams of aluminum is reacted with excess HCl? So very similar to the question to above. I have 2.5 grams of aluminum. I have a lot of HCl, so excess. I'll just edit the previous and write excess. So I didn't really have to worry about that part. So I know this is not a limiting reagent question, which is a concept you learn later on. And they're wondering about how much gas will be produced. So that means, well, hydrogen gas is the only gas produced, and I need that in grams. All right, so recall from the first part that first I need to balance the equation. Okay, so balance the equation. Aluminum. So I have one aluminum on the left, one aluminum on the right. I have one hydrogen on the left, two hydrogens on the right. For chlorine, I have one chlorine on the left and three chlorines on the right. Well, I need to make sure that my three chlorines, we're working it out so that it's like an even number. So let's try putting a 2 there. So if I do that, I have 6 chlorines on the right. So that will force me to have 6 chlorines on the left. And so the chlorines are matched up. There are 6 hydrogen on the left, and there are going to be 3 in front of the H2 to make 6 hydrogens on the right. And lastly, the aluminums. Go back to the aluminums. I have 2 aluminums on the right and 2 aluminums on the left. And this is like the most reduced kind of coefficients because I see 2, 6, 2, 3. It can't really be reduced anymore. And so we can stop there for balancing the equation. So the second step is find the amount of moles of aluminum. Alright, so I have a mass of 2.5 grams. I need the molar mass or atomic mass of aluminum, which is 26.98 gram per mole. Okay, so for the N, I'm going to do the mole train. And so, or you can use the mole train or the equation. So I have 2.5 grams. So remember, I want to get rid of the grams to get to the moles. So I'm going to put what on the bottom? I'm going to put 26.98 grams on the bottom and 1 mole on the top so that the grams cancel out. And I have, for the amount of moles, put that in the calculator, 2.5 divided by 26.98. And I have 0.092661235 mole aluminum. So the second step is, after that, I need to use the coefficients in the balance equation to help me get the moles and then the grams of hydrogen gas. And so I noticed that for aluminum, I have 2 aluminum, and for hydrogen gas, I have 3 moles of hydrogen gas. So I'm going to have to use some math concept to figure out the number of moles of hydrogen gas. So it's not as simple as the previous. It wasn't just 1-to-1. So I can't just copy down the 0.09266. So what I have to do is, okay, so I have 0.09266 moles of aluminum. Well, according to my balance equation, I have 2 moles of aluminum. 2 moles of aluminum. Okay, equals. So when I have 2 moles of aluminum, I have how many moles of hydrogen gas? Well, look at the balance equation and I have 3 moles of hydrogen gas. But I have X moles of hydrogen gas. Because I don't know how many moles of H2 I have when I have 0.09266. So once I set up an equation, like a proportion equation like this, I can crisscross, so cross multiply to try to get x by itself. So I have 2x equals about 0.27798. Keep that in my calculator. And then I have x equals, well, divide both sides by 2 to get x by itself. And I get 0.138991 mole H2. And for the most part, I'm not really rounding until the end so that my number is precise as possible. So we are here, we found the balanced equation. Second, find the amount of moles of alumina. Third, we use the coefficients as a way. We use the mole-to-mole ratio. Mole-to-mole ratio, and that was from the coefficients of the balanced equation. And so finally, I have kind of like a fourth step, which is to find the amount of hydrogen gas. So I have 0.138991 moles of H2. So in order to find the mass, well, let's take that number, 0.138991 mole of H2, and I want the grams of H2. And I'm forgetting that again. I need the molar mass. I need the molar mass of H2, and that is just 1.01 times 2, which is 2.02 gram per mole. And so it's just a matter of setting up our mole train correctly. So if I have moles on the top, I want what on the bottom? I want the mole on the bottom. So 1 mole on the bottom. So that those units cancel out. And I have the 2.02 grams on the top. So my moles cancel out. So those two numbers multiplied will get you 0.28076352285 grams. And according to my question, all the numbers that I used, this is the least significant digits used, so my final answer will be in 2 significant digits. And so my answer is 0.28 grams of H2. That leads to my conclusion, which is 0.28 grams of H2 is produced. So, main ideas. See. So, main ideas is 1, balance the equation. 2, find the amount of moles of aluminum. So, the reactant. We don't have to worry about the hydrogen chloric acid because it is an excess. So, it's the amount of aluminum, in this case, that predicts the amount of product produced. And so second, find the amount of moles of aluminum, so using the mole train or the equation. And so once you get the mole amount of aluminum, we're going to use the balance equation to get our mole-to-mole ratios. So for every 2 moles of aluminum, I get 3 moles of hydrogen gas. And so I had to set up proportion kind of setup so that within the denominators, I wrote 2 moles of aluminum will get you 3 moles of H2. Well, I don't know how many hydrogen gas will be produced for 0.09266 moles of aluminum. So we set it up that way, and that way we did cross multiplication and we got x by itself just by getting just doing simple rearranging. Once we got 0.138991 moles for H2, we used the molar mass 2.02 gram per mole, and again we set up a mole train so that we could do 0.138991 mole, and the moles are going to be on the bottom so that those can be canceled out, and so that you get the final amount of hydrogen gas at the end, and so you get 0.28 grams of H2 is produced. And you're working on the Intro to Stoichiometry practicum after that.